Good morning. So we are going to continue after taking the midterm that was graded and posted on Canvas, and grades were all updated with respect to it. Some people never sent me their midterm exam, and I'm wondering what is happening and if they planning to continue in this class. I sent emails asking about that, and if you received my email that says that I need your work, well, then just reply to it, because otherwise I'll have to drop the person from class, because I don't want to fail anyone if you don't attend and don't send any emails to me and don't send me any work. I guess that's the only way to be in class, in online class, to email some work. I know someone told me, Alex, my other instructors do whatever. Well, other instructors can do whatever they like, but I guess you saw the syllabus and you saw how I teach this class, and if you agree with that, then you are in class. If you like some other instructor, you can always switch to some other section, because I just sent you work by email and expect you to email me back, and I monitor your email. That's important that you actually check your emails, because the semester is coming to an end, and it's 2 more class meetings. So besides today's, we have another class meeting a week from today, and then there'll be a final exam. So not much time. It's only 6-week semester. So one needs to, I guess, put it together and take it seriously and be done with the class. It's not hard. I'm trying to make it be very reasonable in terms of the time that you can put into it. I don't make you work days and nights. I asked you last time to look at the recordings that follow midterm practice. So that's number 12, 13, and 14. So today I'd like to continue discussing this, to look at a few more of those lectures, just to let you know that we really don't have much time, because the final exam is coming in actually 2 weeks from today. So we have next week and week after. And well, one needs to take it seriously and get a good result. You already have a good start. I'm very happy with the results of the midterm, and the final will be in the same format. So I'm sure you will be able to make it if you made it through the midterm. And those people that did not send me their midterm or their homework, well, send it to me. I'm waiting. So please don't wait, send it, because when the final comes, I won't be able to give you lots of extra time after the final, because I'll have my own deadline to submit grades to the college. And again, I'm trying to do my best to help you out to get the best possible grade, but it's not only on me. So please also check the recordings and do this seriously. And I'm also referring to this YouTube channel, the one that I just opened here, with all those lecture recordings in it. And I'm sure you can definitely make it if you put some time watching those recordings, because they're not very long. They're about 30-40 minutes. If you watch 3-4 of them per week, you definitely gonna do pretty well. And you can see there are 2 last ones also refer to the final exam, review in here. So those be the ones that discuss the final, that will be similar to the midterm. I think even shorter than midterm, because midterm had a number of parts in the exercise. So in the final, I'll just give you one question, then another question, so that'll be much more compact. So anyways, let us move to chapter 5. So I hope you all have access to our free textbook. It also appears in recordings, but it's good to have the access to it. It's Triola Statistics PDF. And well, if you didn't send me homework, if you need to know the link to it, well, just check out recordings of lectures. Just do same problems. So let me do a problem here, exercise number 3, that discusses a new story of so-called normal distribution. Last time I tried to give you an idea of what this is for. So turns out that pretty much everything that we see around us distributed normally, and that so-called curve. Sometimes people say, Alex, you're going to grade us on curve, which means normal distribution curve, which means that you get as many. So usually it's like C grade area, and there's a D grade and there's a B grade. So same as many B's as D's and same as many A's as C's. And the answer is no, or as F's. I don't plan to give lots of D's and F's. That's why I just prefer to drop people, so I don't want to fail anyone. So I'll try to check and see and wait another a few days. If I don't receive the work, I'll just have no choice but to drop those students that didn't send me their work. And those students should know it, because I posted grades on Canvas. You just see your grade. If you don't see the grade, then it means that I didn't get your email. So don't get frustrated. If I didn't get your email, just send it to me again. Maybe something happened, and I understand it may not be on you. Maybe you don't have a control over the internet, something happened. That's why I just keep reminding people to email me work, and I will accept it. So anyways, normal distribution has its mean at the center. Picture is symmetric. And here in the exercise, let's say number 3, let's say we are dealing here with distribution at the so-called average or mean equal to 172 pounds. Okay. And it also has a standard deviation of 29 pounds. Okay. Mean and standard deviation we call with mu and sigma, just like they did up here in this blueprint. Also, they want to select one man and see if weight is in between 170 and 175 pounds. So what I do is I make a picture, 170, 175, that surround my 172 pounds. And then I'm going to need to find the area of this region, which is the same as a probability that weight is in between of 170 and 175. So we always call our horizontal axis as x-axis, except for the cases when we're dealing with the standard normal distribution. That's the one that in the beginning of this chapter. And standard normal distribution is what I have those little tables for. So I'm going to show you how we can utilize the tables. So we are supposed to be in between of two values of so-called z's that will surround a 0 on the z-axis. The point of story is we always try to convert our values of x, whatever they are, to so-called z-scores. And then to do the conversion, we utilize in the formula x minus mean divided by a standard deviation. It turns out that in this section, they also add number of people in this sample. So in part 8, they use standard deviation over 1. And in the part B, they actually want to use the formula that says x minus mean over standard deviation divided by a square root of sample size n. Well, in the first part of this exercise, I think actually here, they have the square root of n, which is a square root of 1. So this is going to be really 1. That's why people don't put anything here in denominator, because square root 1 really means nothing. But technically, the square root of n is always on the bottom. So let me do this conversions. And to convert these values to z-score, all I need is to utilize the formula that says here x, which is 170, subtract mean that they told us, which is here 172, and you divide this by a standard deviation, which is 29. So you just need to use a calculator, find the so-called z-score that will correspond exactly to my particular value of x. So use scientific calculator. So I recommend you to select Decimus because it's convenient to use to enter this 170 minus 172. So it's all going to be in front of you, and you can just try to enter these numbers yourself simultaneously with me if you're here. And the way to go is just to get this 0.0 with negative sign 689 ... So I just found the z-score that turns out we need to round to the nearest hundredths. So it'll be negative 0.07. I will show you why we have to round to hundredths, simply because those tables for z-scores don't have any better approximation. And then if I find the other z-score that corresponds to my second value of x, so I'm going to have to subtract now 175. Let me use another color so you better see this. So 175, I'll put it in blue. So the formula is really same, but you want to make sure that you change a little bit your value of x. So you're still subtracting 170 and you still, 172, still subtracting 172, and you still dividing by 29. So in the formula that I have up here on the left, we have mean and standard deviation that stay the same. The only thing that change is just values of x. And of course, without a calculator, it'd be kind of tough calculation to perform. It is doable, but it's going to take you a while to deal with this decimals, and that's, I guess, kind of waste of time. So you really want to use a calculator for this class. So when I divide by 29, I got some other value that I will also round to the nearest hundredths. So this will be something like 0.10. So why are we supposed to round it to the nearest hundredths? Well, let me get Triola, that's the author of the textbook, formulas. So I start typing and it already appears. Triola formulas, and looks like some reason it's here on the right side for me. So I just select the first selection in the Google search. It looks like we have the tables, and these tables and formulas, you can see by Maria Triola, they're always available free online, so you can just locate them and now check and see how they're being designed. So in this tables and formulas, we have only, I don't know what's on the right side. Oh, maybe I can close it here. Okay, that's better. So here we have those so-called z-scores that being splitted into two parts. So there is a part of hundreds. So you see 100s, 200s, 3 up to 900s, and the part of the whole pieces. So for example, my first z-score, which is negative 0.07, I need to go to the negative 0.0, and notice that right now I'm in the negative z-scores. So I need to look at the column that corresponds to 0.7, which is up there on the top. Let me scroll this down a little bit so we can better see this. So we need to basically find out when the row meets the column. So here I have 0.7 for the column and negative 0.0 for the row. So when I compose that negative 0.00 basically together with 0.07, then I will get that z-score that I produce. In other words, I always try to see the separately place of hundreds, which is given in the column. So where the row and the column gonna meet each other, and that happens the very last row and the column under 0.07, you're gonna get the area from the left side, which is 0.4721. 0.4721 is going to be the area of this so-called tail. So tables always give me area from number to the left, and that's actually what they say here. Tables don't care what you're trying to find. They always give you the same thing, area to the left. Okay, we'll keep this in mind, and now I'm going to have to locate another z-score, which is positive 0.1. Since it's a positive, I need to use another page of this tables called positive z-score. So if you scroll down a little bit, you will see that positive z-score. And then 0.1 will be very close to us. It's right here. Please notice that 0.1 has a 0 for hundreds, right? I put that 0 purposely so we can see that we're actually in the very first column, since there are no hundreds, or actually 0 of these hundreds, because all I care is to see where we have the actual so-called probability that corresponds to this value. And it is 0.5398, and this area will also be to the left, so it will contain what I need, that one marked in black, and also more of that tail to the left. So there's 5398 is here. And this is great because now I can give them the answer on the probability, which is going to be always a difference of these two areas, always. If you get two of them, then you're always going to subtract the smaller from the larger. So you subtract 4721 from that 5398 and see whatever comes out. This is your answer. You can use a calculator. I can try it by hand. 53 subtract 47 looks like it's 0.06. So this is it. This is the probability of what? Let me read it again. Let's see what we just found. If we select one man, what's the chance that height is in between 170, or actually weight is in between 170 and 175 pounds? And that's what it is. The probability of that is about 6%, close to 7%. There it is. So looks like we've got the result. And this is great. And why don't I do part B of this exercise, which is now going to have a little extra in it. It's the same thing, but now they select 64 men. So number of men is 64. So it turns out that the whole story will be repeated here the same way, because you're gonna have to find the area in between of two possible values. But when you calculate your z's, you're gonna have to have a little extra in denominator. So I can copy the same thing as I did for the first value. It's 170 minus 172 divided by that 29, but now we put it over square root from 64. Some people say, Alex, this is 8. Okay, this is 8. But the point of story that now we're dealing with the average weight of 64 men. So we can get this calculated. So notice if I compare with my part 1, it's the same thing, but a little extra in denominator. And it turns out that the second z for the other part will be pretty much the same. So where should I do it? Maybe up here, so the whole thing fits. So the second value of z will be also 175. Subtract that population mean 172 and divide it by 29. But now we put this over square root from that 64. So that's the formula for calculating those z-scores. Again, this is all needed so we can utilize those tables. So what are the numbers? Well, let me go back to the calculator. And you can enter it the way it is, or you could just modify your denominator a little bit. So you can say, put this 29, you just click on the same place and just change it. So you're gonna divide this by a square root from 64. Or if you like to help your calculator, put 8. Calculator really doesn't care. So I would just enter it the way it is. And notice, of course, the answer will be a little bit different, right? So what is this? 8, 2, no, actually 83, right? I'm going to round it because, again, in those tables, remember, we have only place for hundreds. And this is going to be actually right here, 0.83, because we just utilized the number on the right. Right? So I need to be careful in this result. So I put answer 170 minus 172 over 29 over 100. Oh yeah, thank you for letting me know. I wasn't careful. I had to put 170, 170, right? I wrote 170, so I better put 170. Okay, thank you. That one will be the second. Appreciate it. But anyways, you calculate one, you calculate another, and at the end you get the result, right? So anyways, I see you already better than I had this. That's great. So it looks like we're going to be within the left one, which is negative 0.55, right? You say I have to be careful. So 55 has to be negative. It's right here, right? And then 83 will be positive, right? I just did it with 83. How I did it? Well, you should just go back and adjust to switch 170 with 175. So that's our 83. 82.7, but we rounded to 83. All right, so same story. Now we need to find both of these numbers in the tables, right? So let me get this tables back. And, well, there'll be a little different numbers. But the good thing, we already know how to use these tables. So let's use it again. I need 83. So the row was 0.8 and the column under 0.03. They're gonna meet right here, 7967. Well, let me highlight this region. Maybe I'll put it in green. So that's gonna be a big region. Notice it's bigger than the previous. We'll see why. So 0.7967. That's for the positive area. Well, for the positive z-scores, and I'll go to the previous page for the negative z-score, because now I need to get this second value. I want to clean this a little bit, it's too messy. So what you need is to get that negative 55, right? So now we're looking at the little row with 0.5 because they're negatives, so it's right here. And also column under 0.5. So we've got some number here. And this is going to be the area always from the left side. So this is tail 0.2912. Okay, 2912. And again, we always subtract. So from this one, we subtract 2912. And whatever the answer is, 5, 5, and then be 0, and then 5. Oh, lots of 5s. So this is the answer. Notice the probability is close to 50%, actually a little bit more than 50%. It used to be only 7%, and now it's about 50%. So how come it's increased so tremendously? Remember, probability is always in between 0 and 100%. And now we got first answer for one man, the chances of that man to be in that particular category, not very high. Well, because one man could have any weight, could be less, could be more, so it could be anything. But if you're looking at 64, that's a lot of males, right? 64, and you look at their average weight, well, then the average weight of 64 should be close to the average weight of entire population, which is 172. So it's more chances that they will be in that same region. That's the why we have that thing happening. So we got the result in here, and that's pretty much all I wanted to talk about in this case. So that's all related to z-scores. And then once you find z-scores, you use those tables. And this is being discussed quite deeply in those lectures. So let me, maybe I can clean this mess, because I already recorded it. If you want to see it again, you can just watch that recording that I will send you right after the lecture end. So here we have a set of lectures related to these tables. In fact, you can see that pretty much everything is related to tables. So I ask you to watch up to 14 up to date. So it'd be good if you watched the next 4, because they'll give you a good start into it. And then by next time, by next week, Monday, and then we'll continue discussing whatever is left next week on Monday. So I'll ask you also to watch 19 through 22. And then a week after, when we have a review, I will definitely discuss some more stuff that are going to be closer to our final exam, which is actually not a final, but test number 2, because it'd be not any harder than test number 1. If you did midterm well, then I don't see the reason why you should not do same as well on that final exam. So I'm going to stop recording and see if you have any questions for me right now.